Hi, I'm Daniel with Polymath Classical Tutorials, and in my last video I raised the question, what is classical mathematics? In this video I'd like to give you an illustration or an example, a practical example, and show you how I teach geometry using Euclid. Now this is going to be a pretty informal video, it's going to be a fairly technical video, so I'm not going to be actually teaching Euclid. I'm going to skip over a lot of stuff that ordinarily I would teach if I were actually teaching Euclid. And instead I'm going to show you more or less the framework that I use to teach Euclid. So I'm going to show you how I structure the learning experience, how I introduce Euclid, how I teach the propositions and constructions, and how I tie everything together using context and narrative. So first, let's talk about the learning experience when we come to Euclid, or really when we do anything. I think it's useful to begin by first thinking about how it is that we actually learn. So the thing I want to point out is obvious, I think, to most teachers, but I'm going to say it anyway just because sometimes it's useful to say the obvious. And that's that we don't learn linearly, right? You don't just go from point A to point B when you're learning. That's not how learning works. Learning looks more like a spiral. When you learn, there is progress, obviously, but you often review, recover, relearn stuff you've already known, right? So you might end up hitting the same point or the same piece of information or the same idea several times in the learning process and going over it and learning it each time at a different level and in a different way. And ideally, every time you learn this concept, again, you do so in a more profound manner, right? So you add depth to your knowledge. I think we can give our students this experience just by, I don't want to say reviewing with purpose, but by being conscious of how a lot of these concepts overlap and are interwoven, and you can always point back and say, look, see, we had this concept over here. It's the same thing, but now over here it looks slightly different. We've learned it now again in a different way. So the reason I say this is because I structured the learning experience around this idea. And I do this by emphasizing different levels of focus. So there are 3 levels of focus. I begin at the broadest level, and you can already see where this is going. So I go from the broadest level of focus to an intermediate level of focus. Intermediate level of focus. Let's see. There's the broad focus, intermediate focus. And then thirdly, we have, you guessed it, the most specific level of focus. Right, so 3 different levels of focus. You've got broad, intermediate, and specific. Okay, now how do I apply this to geometry? Well, I'll show you. When I begin broadly, what am I doing? Well, I am situating the lesson in context. So this provides the context for the lesson. Here's the lesson. And then this is the application. Whoops, let's try that again. Here's the application of the lesson, all right? So you have the context for the lesson itself, and then the application of the lesson. So I'll show you exactly how I apply all of these things to Euclid's elements. And so I'm going to walk you through what I typically do in the first 2 weeks when I'm teaching Euclid's elements. We begin in book 1, and the first week, my first lesson is all in the definitions, axioms, and postulates. And usually when I do this, my classes are pretty long, like 2 hours once a week. And so if you have a shorter class, you'd want to do maybe half and half. So you spend the whole week still covering just the definitions, the axioms, and postulates, but you may not want to do it all in one go because that can be a lot. But that's entirely up to the way that you run your class. So we begin before we really get into all that, we begin at the broadest level of focus. So what am I doing here? Well, here I'm situating Euclid in history as a person, right? So we answer the question, well, who is Euclid? When did he live? Who were his contemporaries? What was math like when Euclid was alive, right? Did he invent geometry? Well, no, but he did organize things. He came up with some of his own proofs, etc., etc. So we locate Euclid in history for the student. Then we also talk about Euclid's how Euclid affected the history of ideas. And so you can talk about Euclid's influence, right? Again, still focusing on history, right? The historical impact of Euclid, who he was as an individual, his effect on the history of ideas. One good way to do this, by the way, is to think about Descartes. You'll remember Descartes, of course, not only for the Cartesian coordinate system, but also because he's the guy who said, I think, therefore I am. Now, what a lot of people don't realize is that the reason he said, I think, therefore I am, it's because of Euclid. Here's how that works. Descartes loved geometry, as we know. He was obsessed with the geometric method, which is, of course, the method where you begin with some axioms and then you build some propositions on the axioms and then you build more on top of those and more on top of those, and before you know it, you have this mountain of absolutely certain knowledge based on a few things that you just had to assume, right? Or that you take for granted, or that you take as self-evident truths. So Descartes thought, why can't we do this with philosophy? And so the reason he said, I think, therefore I am, of course, is because he was engaged in this project of doubting. And so he was trying to doubt everything he could away. Why? He was trying to get to the fundamental philosophical axioms. Two things which either were self-evident and therefore not doubtable, or things which simply couldn't be doubted for some other reason, right? Well, the one thing that he latched onto was, I'm doing all this doubting. In order to be doing the doubting, something has to be doing the doubting. If the doubting exists, I must be that thing doing the doubting, therefore I must exist. If the doubting exists, which it does, right? So I think, therefore I am. But the reason he embarked upon this project was because, essentially, of Euclid, right? He was applying the geometric method to philosophy. And so Euclid's impact has gone far beyond mathematics. Euclid's impacted even philosophy. So we start really broadly situating Euclid in history, situating his book in the history of ideas, and then we proceed to the next level, which is the lesson itself, right? So in this case, because when we're doing Euclid's first starting off with Euclid, what the lesson is, as I said, is it's just the definitions, axioms, and postulates. Okay, so here I have an online version of Euclid's Elements. Because everything I do is online, I use this every now and then. I prefer to work out of a book. You probably do too, but it can be useful, especially like right now. So Euclid has all these definitions. He has 23 definitions in Book 1 of the Elements. There's 23, right? He's got some postulates that follow. He's got some common notions. So what I do in a class after situating Euclid in history is we talk through the definitions. We read definition 1. A point is that which has no part. What does that mean? Right? We spend some time discussing that. What does it mean that a line is a breadthless length? What does it mean that the ends of a line are points? And so this is where you would apply your Socratic teaching methods, right? You would ask really good questions of your students, getting them to think and not just nod and blindly accept these definitions, but to really probe them and think about what these definitions imply, how they're different from other ways that we might define things. I will also, just as an aside, draw your attention to definition 4. I don't know what this means. I'll just tell you. I've read some commentaries. I don't think they know what it means either. This is one of those things that it's just a definition Euclid's got. I have no idea what it means for something to lie evenly with the points on itself. I've come up with a couple theories. I've read some theories. I don't think anybody's 100% sure. But even that can be something you can discuss with your class, right? Say, well, gee, this is a really weird way of defining a straight line. How else might you define a straight line? Why do you think maybe he does it this way? What perhaps could he mean by saying it like this, right? Postulates. Then we continue to talk about postulates. And like I said a minute ago, my classes are usually, well, when I teach Euclid's Elements, my class is usually 2 hours, roughly 2 hours once a week. So we cover all this stuff in a single class period. But if your classes are shorter, you might do maybe some of the definitions one class, more of the definitions and the postulates or something the next class. But I wouldn't go any further than the postulates and common notions during the first week. I think that's sufficient for a week. If you really wanted to push your students, you could probably push them into Proposition 1, but that would be the very, very furthest I would go. Because it's just so much to take in, and you have to have time to talk about all these things. So you need to talk about all the postulates. Postulate 5 is worth at least a half-hour conversation on its own, I think. For reasons that I can't get into right now, but there's a lot to talk about there. So we talk through all of these things. Okay, that's the first week. Now, what we've done so far is we've gotten to the lesson, right? So I've broadly situated Euclid and his ideas in time and history. Then we go through the lesson where we actually talk through the reading for the week, which would be the definitions, postulates, and common notions. Then thirdly, what do we do now? Well, remember, we're going from the most specific to the least specific. I said that backwards. From the most general to the most specific. There you go. Now we have the exercises. You have to have something for them to do, right? To better internalize the material of the lesson, because just reading it isn't going to be enough. So what do they do? Here's what they do. Study questions. You give them questions that would cause them to think really carefully about the definitions, about the postulates, the common notions. Ask them to compare different definitions. What are the similarities? How are they different? What do you think this particular definition means? Why do you think Euclid phrases this in this particular way? What is a postulate? Right? Why are the common notions what they are? So these are the sorts of things you would ask. And also, I'll just say, practically speaking, the way that I would do this is I would actually have students do the reading before coming to class, do the exercises also before coming to class. That way, in class, the exercises can inform the lesson. So that way you can have a more fruitful discussion because the students have already thought through the exercises before coming to class. So they'll have something to say, right? You've probably had classes where you ask a great question and nobody has any idea how to answer it. Sometimes people need time, right? This provides them with that time. But so I would usually have them do these exercises before coming to class. But you still have those 3 levels of specificity that they have to engage with the material, right? Okay, so that's the first week. What about the second week? Well, at this point, you've covered all of the definitions. Sorry, I'm scrolling here. All the definitions. You would have covered the postulates as well and the common notions, and now the students are ready to tackle the propositions. So what do you do? Same kind of thing, okay? We have to have the broad focus and then the other focuses here, right? The intermediate and the specific. So again, the broad focus in this case is going to be broader context. Again, we are providing context at the beginning of every lesson in some form. And what this means is we would have the students just flip through book 1, right? So just to look at book 1 of the elements, and you could ask them, what do you notice about the diagrams? Just looking at the diagrams, what do you notice? And you'll probably get answers like, well, there's a lot of triangles and then some parallelograms. And that's great. You can ask, what does that mean, right? What would that suggest to you? What do you think that book 1 is ultimately about? And they'll probably say, well, triangles and parallelograms. So yeah, great. Why do we make the leap from triangles to parallelograms? Why do we go in that particular direction? Why not start with parallelograms? Why do we start with triangles? So you can have a conversation about that. But at the same time as you're doing that, you're orienting the current lesson within a broader context of the book as a whole. Then what do you do? Well, now again, you provide the lesson. And the lesson, over the course of the whole week, so this wouldn't be the daily lesson, but over the course of the whole week, you would take them maybe through propositions 1 through 3, or maybe through 4 or 5 or 6, depending on how much you plan to have them cover. I wouldn't do more than the first 6, though, propositions in the second week, because more than that would be a lot, I think. But you can get through the first 6, but depending on the age and skill level of your students, you may need to back off slightly. Okay, so assuming we're doing the first 6 propositions, again, have the students read these ahead of time before coming to class. Okay, so then what does class look like? Well, this is what it looks like. I present the proposition to the class. They've already read it at this point, right? But I present it to them. So I give them the proposition in my own words, and I present it using the software, because I do everything online, where I can actually draw using like a compass and ruler. If you have a chalkboard or something, then you'll just have to freehand all this stuff rather than actually drawing it, unless you have one of those like blackboard compasses, which I've seen a couple times, which are super cool. But this is what I do. So I talk them through the proposition. I construct it for them as I'm talking, and I explain everything Euclid's doing in my own words, and then I do the proof, right? I explain to them that this is now an equilateral triangle, again, giving the proof in my own words, following Euclid's order. The reason I'm doing this is because I'm modeling for them how to present a proof, because this is something I'm going to have them do later, pretty soon, actually. So I present that, and then we talk about it, and I make sure that they can also do this, because it is a construction. So they need to know how to actually draw this figure, and so you may need to talk them through how to use a compass and a ruler and all that, or a compass and straight edge rather, to be able to draw this figure. But they need to know how to do that, and they need to be able to do that. And then we move on to the next proposition, and depending on their confidence level, I will usually present this one as well to them. But this one's even more important, that they really understand how to draw on their own. And so you'll need to guide them through it, and what you might even want to do is present this in your own words, walk through the proof, and then have one of your students go up behind you and present it again to the class in their own words, right? Just going through it again. If they're able to do that. They may not be able to do that yet, and that's okay. But you do want them to be able to at least do this whole construction on their own in their notebooks or journals or whatever you have them using. The third one, same thing. Present this one as well, but then I might have some students try to actually do this. And if I'm teaching in person, I actually will have them do it in class, in paper, because I can walk around the room and I can look at the paper and help them figure out where the compass needs to go to be able to do this one correctly. Because this one, the diagram is deceptive. The diagram is actually far more complicated than for Proposition 2, because it includes Proposition 2. So Proposition 2 is actually in Proposition 3, it's just not represented in the diagrams. But on paper, it certainly would be, so that can be pretty complex. Proposition 4, it's a bizarre one. It needs a lot of, it deserves quite a bit of conversation for reasons that I won't get into, but we talk about that. And then proposition 5. This is where I really begin to emphasize to the students that they need to be the ones presenting. And so usually nobody's really all that keen on volunteering to present. So you might just have to pick somebody, which is usually what happens. But I tell them, don't worry, if you get stuck, I'll help you. And at this point, I usually just let them read off of Euclid's Elements, so they have the text in front of them, they're drawing it, they're walking through it with the text in front of them. It's very wooden. And it's one of those things where they're not really understanding what they're reading, but that's okay. Because then what you do, after they get through it all the way, you congratulate them on a successful presentation, and then you ask them to summarize what they just did in their own words. Now that's the real test. Because if they can summarize in their own words what they've done, that means that they actually understand what's being said in the proposition. It's really easy to get bogged down in all the details, especially when each angle has 3 letters to name it. Your brain will start to hurt almost immediately. And so it's so easy to get lost, and so lost in the details that you don't actually know what's going on. The best thing to do then is to work through the thing first once, have a rough idea of how it works, and then go back and try to summarize in your own words, not naming the angles with 3 letters again, but just pointing at them, saying, well, this is saying this angle is equal to that angle, and because that's true, this other thing is true. And if they can do that, then they've really got it. And then we move on to proposition 6 and do the same kind of thing. Okay, so that's how the lesson goes. What about the 3rd level of specificity here, the exercises? Exercises, there we go. Exercises. Well, this is where, as a teacher, it becomes a little bit difficult because now you have to create exercises that are analogs to the propositions, to the kind of work that the students have done in the propositions. You have to produce analogs that they have to work through themselves or construct themselves to really begin to internalize everything that they've read. So what this means then is you have to provide proof exercises where they're actually writing out proofs the same way that Euclid does, and you'll need to come up with construction exercises where they can use construction. Is that how you spell construction? Construction. That looks wrong to me for some reason, but we're just going to go with it. So you need proofs and construction exercises so that they can be using the things that they've just learned. Because if you don't use it immediately after learning it, you're going to forget it. Now, like I said, this is really hard to do because it's difficult to come up with analogs to Euclid's problems, to his propositions and constructions that are at the right level of difficulty for your students. There aren't a whole lot of resources that would give you exercises taken directly from Euclid's Elements or directly based on Euclid's Elements in this particular way. I will say that I have done this in my guidebook that I've written for Euclid's Elements. It's called Classical Math 1. You can find it on my website. And I have lessons where I've provided exercises, where I've got introductions which provide the context. I lay out what the lesson is. I give you exercises at the end. So it takes a lot of the difficulty out of teaching Euclid. Now, as a teacher, you'd probably still want to do all the lessons yourself. It's not one of those things you can just pick up and not having looked at it and teach. You still need to do the work. But at least I've done some of this for you in that book. I can provide the exercises and whatnot. Okay, so we've done the first 2 weeks of Euclid. First week, just focusing on definitions and the axioms. Second week, we get through the first 6 propositions in Euclid's Elements, talking our way through the general context of book one, talking our way through these propositions, and then doing some exercises to emphasize and review and really set these ideas in our students' minds. So here's another thing that I do, and this becomes important the further on you go, all right? So you have to put everything together, right? And what I mean by that is you need context, constant context. Now, fortunately, Euclid and some of these other great mathematical writers of the past, they do this in the work because the works are building on things that they've covered in the past, right? So Euclid's Elements is constantly building on itself, so it has its kind of own internal context, which is super important, and it's great. And you can use this to constantly orient and reorient students within the work itself. And so here's what that looks like. As you go along, students will be, they'll have the tendency to forget where they've been and where they're going, and they'll just get bogged down in the details that are currently in front of them, the proposition immediately in front of them, and they'll forget everything else. So what you have to do is you need to reflect on past lessons, right? And you need to have them identify themes, motifs in the lesson, right? So what do I mean by this? I mean, one of the themes that you see in Euclid's Elements, especially in book one anyway, there's a number of themes throughout the Elements, but in book one you see there's a theme of congruence, right? Figures that are congruent. Now, Euclid calls them equal, but when you see it, you'll know that he means congruent. And so you can trace the ways in which he talks about and thinks about and uses congruence through the various propositions. That's a really useful thing to do. Other things you can trace just by looking at the diagrams. He's talking about triangles here. Suddenly he switches to parallelograms, right? And so if you can identify these themes and the ways in which Euclid is using certain ideas like congruence, ways in which he's using equality, inequality, all of these things, you can actually trace these patterns through the course of the book. And doing that essentially creates something like a story. Now I'm putting it in scare quotes because it's not really a narrative, right? But you can construct it like one. You can explain how Euclid does this, and then this, and then this, and then this, and how it all fits together. And that produces something like a story that provides a kind of context, and the student will understand how what they're doing now fits into this trajectory. And that's really useful. It also helps them understand, because you're seeing the unity in mathematics, and well, it helps them understand a little bit better the beauty of mathematics, because there's beauty in unity. And it's really hard to see the beauty in math if you can't see the unity in math. So creating this story by identifying themes and motifs is a really great way to do that. Okay, so I think that's really the main thing I wanted to point out here. So I'll just say, I hope that this was helpful. Sorry that this was a little long. I meant it to be fairly short, and I guess I'm a little long-winded. But I hope that you find this useful in some way as you are thinking about how to maybe work Euclid into your curriculum or into your math program or the course of study for your students. And I would also encourage you, if you found this helpful, to check out my Euclid for Parents summer course. I teach it every summer. It's actually for students and parents and teachers. It's a combined class. And so in that class, we cover all of book one. And so we do this live online during the summers. And I would love to have you join us if you're interested. But again, I really hope that this was helpful. And let me know if you have any questions. I'll be answering questions in the comments, or you can send me an email. I'd love to hear from you.